Oh, welcome and thank you for joining. In this lesson, we'll explore the concept of logarithms. We are working on the unit of exponential functions and we're trying to solve lots of exponential equations. And logarithms will help us solve some very interesting exponential equations. So logarithm is perhaps the single most useful arithmetic concept in all sciences, and you've probably used logarithms in chemistry, in grade 11 chemistry already. But in this lesson, we'll go over the basic meaning from the mathematical point of view and how we use it in solving various equations. Understanding logarithms, or as we know, or as we call them, logs, is very essential in understanding many scientific ideas. So to start with, the very definition of logarithms is very simple. Logarithm is just another name for exponents. And for short, we call logarithms logs. And if you look at your calculator, you will have a button on your calculator that has the exact same word, the word log. So if you look at this equation here, connects numbers 3, 2, and 9. So we say that the base 3 raised to the exponent 2 is equal to 9. Now, this is an exponential statement, and the way that we could read this is the number 2 is the exponent that we must raise the base of 3 in order to obtain the number 9. Now, we're going to try to write the same statement, this statement here, but now we're not going to use the word exponent, but we're going to use the word logarithm. So we're going to say number 2, so number 2 is, so same thing, instead of the word exponent, we're going to use the word logarithm. We must raise the base 3, in order to obtain number 9. So as you can see in here, this statement up here and this one down here mean exact same thing, and the only difference between them is here you use the word exponent, here logarithm, but they are synonyms. That's how we want to think about it. Now, if we want to put this into a shorter mathematical statement, we're going to say that number 2, now in mathematics means equals, and instead of the word logarithm, we're going to write the word log, just like we see it in the calculator. The base of 3 will be written right at the bottom or at the base, or you can think of it as the base of the word log, in order to obtain number 9. So the number 9 is the number inside the log. So the two statements describe the same relationship that exists between the numbers 3, 2, and 9. So we call 3 raised to the exponent or to the power 2 equals 9 an exponential statement, and we call 2 is or equals log with base 3 of 9 a logarithmic statement. Now, to evaluate logarithmic numbers, obviously we're going to use calculators, and I'm going to ask you now to grab your calculator and try to find the log button on your calculator if you don't know it already. Now, some calculators, we have the option of adding a specific base. So for example, they would appear like this. So when you press log, then the calculator will immediately show that little box in here that allows you to put a specific base in the calculator, but some don't. So if you have a small little box in here at the bottom and another one in here, that means that you can enter any base you wish. But if you don't, it means that you're not allowed to change the base, and the base will automatically be equal to 10. So it is known, so when we don't write the base of the log term, we automatically assume that that must be a base of 10. It is a little bit similar, but not exactly the same as when you have number 2. So when you don't write the exponent, then you know exponent is 1. But this is done by agreement, by the way. But I want you to think this way just so that you can remember it. Now, normally when the base is 10, we don't write it at all. And it is similar to when you write square root of 5, so we don't write the number 2. So similar idea as I was explaining before. Now, if we have a logarithm with a specific base of some number, and we are not allowed to enter a specific base in the log, so what we do is we just calculate this as log of 9 over log of 3, and we keep the base the same, 10. So you can actually evaluate this log with any base. So if the calculator allows you, so you can insert any base you wish if you have the first type calculator. Now, let's take a look and see how we are going to use log, how we'll use log in order to solve equations. So when you look at the equation 2 to the power of x equals 8, we're going to say this is an exponential equation. The unknown variable is in the exponent. And if we want to solve this equation, we have solved plenty of such equations, right? Then what we try to do is make the both sides, or make the terms in both sides have the same shape. So because we want to compare apples to apples. So if we have an exponential number in the left, we want an exponential number in the right. And number 8 can be written as an exponential. Obviously, we need the bases to be the same. We've already gone over how we solve these types of equations. So the base of 2 will be to the power of 3. Now, as you can see, we have two exponential numbers that are equal to each other, and their bases are the same, which tells us that the exponent is 3, so our x equals 3. So we know how to solve equations such as this because in this example, we are able to express the right side of the equation as an exponential number with the same base. Now, we're going to take a look at the next equation, 3 to the power of x equals 8. So when you look at the left side, you have an exponential with base 3. So what that means is that we're going to try to write the right side as an exponential also with base 3. But you know that number 8 cannot be power with base 3. So what we do in this case, and this is when the log helps, is we're going to write this exponential statement as a log statement. And we're going to say x is or equals the exponent, or we're going to say the log. We must raise the base 3 in order to obtain number 8. And from here, we are going to use the calculator to evaluate this number. And if you see the number 8 inside the log, that will stay in the numerator. If you see 3 in the base, that will stay in the denominator. And let me color code them. And what we have to do here is just use or write the word log. And what that means again is that we are taking the log with base 10 of number 8 over log with base 10 of number 3, which is pretty much the same as log of 8 over log of 3. And you simply use the calculator to evaluate this number. And I'm going to do the same thing here with my calculator. So log of 8 divided by log of 3 is equal to 1.89. We want to round to 2 decimal places. Now, one thing that I want to warn you about is that you need to keep the numerators and denominators in brackets when you perform the division. And that is because if you forget to close brackets, then you're going to take the log of 8 that is being divided by log of 3, so it will give you the wrong answer. Okay, so play with your calculator to get to know how that your calculator works in this case. So let's take a look at a couple more examples. So we have 5 to the power of x equals 0.2. So in this case, what I can do is I can write the right side of the equation, 0.2, as 0.2 actually can be in fraction form. So if you want to do this the long way, so in fraction form is like 2 over 10 or 1 over 5. So 0.2 is 1 over 5, or you can write this as 5 to the power of negative 1. And since the bases are the same, then we're going to say the exponents are equal, so x is negative 1. So if we were to use log to solve this, then you would say that x is, so this is what we're solving for, is the exponent, or we're going to use the word log this time. So log with base 5 of 0.2, or we're going to say log of 0.2 divided by log of 5. And that will give you the exact same answer, negative 1. So moving on to the next example, we have 11 to the power of x equals 121 is 11 squared. So in this case, we're able to make both numbers into exponentials with same base. So that means that we have x equals 2. So if you were to solve this using logs, so we're going to have x is the log that we must give the base 11 to obtain number 121. So use the calculator to calculate this. So that would be equal to log of 121 over log of 11, and your calculator will give you the exact same answer too. Now, in the next example, we have 4 to the power of x equals 1. So again, if 4 to the power of x equals 1, we can write number 4 as exponential number with base 4 and exponent 0. So in this case, we're going to say x is equal to 0. If you were to use logs again, you're going to say that x equals the exponent or the log. We must give the base 4 in order to obtain number 1. And that would be equal to, so we said that what's inside the log stays up here, the what's at the bottom or in the base stays down, and then you stick a log to both of them, and log of 1 is equal to 0, and log of 4 would be whatever number it is, but we know for sure that 0 divided by log 4 would be equal to 0. Now, in the next example, as you can see here, we have 3 to the power of x equals, so 7. In this case, we cannot write number 7 as an exponential with base 3. So the only way we can solve this is by using logs. So aren't we thankful that we learned this concept, right? So we're going to say that x is the exponent, or now we're going to use the word log. We must give to base 3 in order to obtain 7. So that would be log of 7 divided by log of 3. And again, careful when you use a calculator. So keep this in brackets, and then you divide, and then keep the denominator also in brackets. So log of 7 divided by log of 3 is equal to 1.77. So that's the answer. And again, round to 2 decimal places. That is a common, rounding. So let's take a look at a more interesting question. You have 6 to the power 3x equals 10. So the exponent is 3x. So what we're going to do is solve for 3x first. And we're going to say that 3x is the exponent, or we're going to say the log that we must give to base 6 to obtain number 10. So that means 3x would be equal to log of 10 divided by log of 6. And now we can isolate x from 3 by dividing both sides of the equation by 3, or multiply by 1/3, same idea. So x will be equal to log of 10 over 3 log of 6. And from here, you simply use the calculator again, log of 10, and I encourage you to just find log of 10 only. You'll notice that is equal to 1. And this is one very important log property. So when the base in here is the same as the number inside, you always get the answer equal to 1. And then divide this by open brackets and then 3 log of 6. And that would be 0.43. So the entire answer is 0.43. And we're moving on to the next example. So I encourage you to try this on your own. It's not difficult. It's the same process. It's just a little bit of bigger numbers. So again, 6x is equal to the log, or the exponent or log, right? Same thing. We give base 5 to get 68. So 6x equals log of 68 divided by log of 5. And if we want to get x, then we divide both sides by 6, or multiply by 1/6, same thing. And from here we get x equal to log 68 divided by 6 log 5. And log 68, divide this by open brackets 6 times log of 5 is equal to 0.44. That would be the answer. Now, let's take a look at another equation. Here we have 2 times 7 to the power of x equals 44. So as you can see, this is the variable we're trying to solve for, is in the exponent. This is the exponential part of the term. There is only one term on the left side. All right, this is the exponential part, and this is its coefficient. So what we want to do first is get rid of that coefficient. So from both sides, we will reduce or will divide by 2. And that will give us 7 to the power of x equals 22. And from here, we know that 22 cannot be an exponential with base 7. And we're going to say our only hope is log. So log base 7 of number 22. And that would be equal to log 22 divided by log of 7. We're going to evaluate this, the approximate answer, so would be log of 22 divided by log of 7. And the answer is 1.59. Next, we have another question similar to what we just did. So we have the exponent. The unknown is in the exponent, and this is only a single term on each side in this case. And this is a single term. It has a coefficient of 100, which means that we should start off by reducing both sides of the equation by 100. And in this way, we're getting closer to our exponent that we're trying to isolate. So 1.002 power x is equal to 1,000 divided by 100 is 10. And again, we are going to convert this exponential statement into a logarithmic statement. So we'll say that that would be equal to the log with base 1.002 of number 10. And obviously, as you practice more, you do tend to do these a little bit faster. So you tend to kind of lose this step because you kind of see right away. So that's log of 10 over log of 1.002. And that is totally fine, actually. And divide here by log 1.002. Don't forget to write the approximate answer as well. So that would be log of 10. Again, log of 10 would be equal to 1 divided by log of 1.002. And we're going to get a fancy number here, 1,152.44. That's a big log, actually. Now, you have a few more practice questions, very similar to the examples that we took in here. And I hope that you enjoyed learning about log. It is quite an interesting concept and very easy to understand, by the way, and very practical, and it does help us solve quite complicated exponential equations. Thank you for learning with me, and bye for now.